Now the second part says to write the equation of the tangent line. Well, here's your slope, and if we only had a point that this goes through, we could use point slope form. Okay, let's do it. So to write the equation, right? You're going to have your point. This is the equation of the tangent line. Remember that. So you have your point, which is 5 comma 3. You have a slope of 2. So it's y minus 3 equals 2 times x minus 5. Remember that's y minus y1. If you need to write that down up here, you can. Y minus y1 equals n times x minus x1. Now, with that, if you wanted to, you could even check this on a calculator. I'll show you how that works here. To get it into a form where you can use it on the calculator, you got to move your minus 3 over here to a plus 3. So it's y equals 2 parentheses x minus 5 plus 3. Leave it like that. Just leave it like that. It'll be fine where it's at. Now I can actually check that on a calculator. Calc check. y1 is going to be your original function, plus 18. y2 is going to be the new guy. So let me show you what this actually looks like here. My batteries are low, and it's recommended that I change my batteries. I'm so happy that they have explained that to me. Okay, so let's say I want to actually do this. So I'm going to have my y1 is x squared minus 8x plus 18. My y2 is going to be the guy I came up with, x minus 5 plus 3. Now, if I did this correctly, this line should only touch this graph one time, and it's at x equals 5. Bam! Now you may be saying, Mr. Ballard, it looked like it touched it twice. Okay, I'll zoom in just to make sure. Where's my thing? Ah. Da-da-da-da, Just to prove it to you, let's do a calculate, intersect, first curve, second curve. Guess one time, 5 comma 3. Now your calculator's pretty stupid, so it actually put a point 0.000014 on here. It's a moron. Don't trust it. It's 5 3. Okay, it's 5 3. All right, so that's what those two lines share. That is how you find the derivative and the equation of the tangent line. All right. Now, is this time consuming? Absolutely. It is 100% time consuming. But that's okay. Once you get to understand these, they go pretty quick. So let me show you about number 2. Go to the back page. X squared minus 3x minus 4. It says write the equation of the tangent line at c equals 4. Okay, so first off, my f of x is given to me. I need to find f of 4, f of c. So that's what? 4 squared minus 3 times 4 minus 4. So 4 squared is 16 minus 12 is 4 minus 4 is 0. So here f of c is 0, right? Let's go ahead and label that. We got our points. We have 4 comma 0. And then you've got x and f of x, right? So let's figure this thing out. F prime at 4, c is 4, is going to give me the limit as x goes to 4 of x squared minus 3x minus 4. That's f of x minus f of c f of x, f of c, over x minus c. Okay? So we can set this thing up as the limit as x goes to 4. Let me take the limit of the top. All your limit rules still apply. So if you could not factor it, you'd have to do something else like your trig rules or anything like that. So we can factor this thing out. We have an x minus 4 and an x plus 1. Alright, so f prime of 4 again is the limit as x goes to 4 of x plus 1, which is equal to 4 plus 1. Right, well, let me rewrite that for you here. So f prime of 4 is 4 plus 1, which is 5. Now remember, this guy right here is the slope of the tangent line. Slope of the tangent line is 5. So now we're going to use our slope of 5 and our point, which is 4 comma 0, and we're going to make the equation. Y minus 0 equals 5 times x minus 4, or y equals 5x minus 4. And we can check that on a calculator if we wanted to. Alright, now I'm not going to take the time to do that. You saw how to do it. Go through, plug this guy in, plug f of x in, and see what it comes up with. And the slope is actually 5. That's not too shabby, is it? Alright, so I want to do something very quickly here. I know these videos are getting to about 15 minutes apiece. I'm trying to hurry, I really am. But I want to do something very quick here without having to go too fast. Functions and the graph of their derivatives. Functions and the graph of their derivatives. Now, if you think about this here, if I wanted to graph the derivative of this, I'm going to come up with some values for x, and I want to come up with some values for f prime of x. Now, f prime of x is the slope at these points, right? So what I want you to do right here, let me write this up here, is to estimate slope of the tangent line. Estimate slopes at x. That's what we're doing right here. Oops, sorry about that. We are estimating slopes at x. Okay, now I'm just going to go from some of the points that I have here. This thing is shifted over a couple, so let's just use nice even points. -2, -1, 0, 1, 2, 3, and 4. Why not? It goes from -2 to 4. Now I want the slope at these points. So very lightly, what I'm going to do is go to -2 right here, and I'm going to estimate the slope of that line. You can kind of see it where I've drawn that in here. Let me zoom in a little bit. Too much. I've kind of drawn that line here. It hits at this point, and it's a slope of roughly 1, 2, 3, 4 over 1. So it's right about 4. Then you go to 1, make your ID touch it just once, put it just ever so right on there, right? So here's 1, at 1 rather. And for 1, now this could go a couple of ways. It's to me it looks like it's right in between 1 and 2. It's not quite 2 because it doesn't really match down here. It's right in between 1 and 2. It's pretty close. It's not quite 2, so I'm going to call it 1. All right, I'm going to go safe, and I'm going to call it 1. Go to 0. Now this one's pretty obvious. What's the slope of that line at 0? Right? That's 0. There ain't no doubt in that one. All right, then you go over here, putting this where it's only going to touch once. Now, notice when I say that it touches once, it will pass through the line. Okay, it will pass through the line. It will happen, and that's okay. That's perfectly fine for that to happen. All right, but notice that it's a negative slope here. To go from this point where it touches up to the other point, it's like up 1 and over 1.5 roughly. Up 1, 1.5. So again, I'm gonna go shy on this, and I'm just gonna say it's the -1. Instead of saying -1.5, it's just gonna be easier if I just keep it with that first whole number. Then you go to 2. 2 is pretty flat, so 2 is obviously gonna be 0. Then you go to 3. 3 is right here. I try and get this to only touch once. And that's up 1 over 1, down 1 over 1. Again, it's pretty close to 1. And then 4. Up here is 4. We get it to only touch once here. And it looks like it's over 1, up 1, 2, 3, 4 again. So 4. Notice that was just an estimation. It's pretty hard to do these by sight, so we estimate. It's hard to do them accurately by sight, so we're just going to estimate. And it's the overall shape that you want to see. And it's pretty cool what actually happens here. Now I'm going to go down to the bottom and I'm going to actually graph this. So I'm going to go to -2 and then go to 4. Now notice this is the derivative, right? So once I get down here, it's actually going to be a point. -2, 4. These are my x values. These are my y values. My x's of the derivative. My x's are just x's. These are the y values for the derivative. -1, 1. 0, 0. 1, -1. 2, 0. 3, 1. And 4, 4. And look at what happened here. It's not exactly perfect, but you can see that this is clearly going to be a parabola. Check that out. So a couple of things that I want you to notice the interesting things that are happening here. Let me make sure I'm okay. I got 2 minutes left. Notice the sketch of the derivative. Here's a sketch of the original. This is a cubic function, x times x times x. This is a parabola. So a couple of things to notice here. Let me back off just a little bit. So the derivative is 1 degree less. It goes from an x cubed up top, x times x times x, to an x squared in the bottom. So the derivative is 1 degree less. And the last thing here, if you have f prime of x and you compare that to f of x, think about the critical values here, the zeros. You've got 0, you've got 2, you've got 0, you've got 2. What's the comparison between these things at 0 and at 2? Well, notice it has to deal with slope, right? Where the slope is positive, or where the slope is positive, your derivative will be positive. Where the slope is negative, your derivative will be negative. Where the slope is positive, your derivative will be positive. So for f of x, you've got positive to the left of 0, negative in between 0 and 2, and a positive to the right of 2. For f of x, it's increasing to the left of 0, the slope is positive, decreasing between 0 and 2, the slope is negative, and increasing to this right hand of 2. And we're going to talk about what that means for us a little bit more as we go on. But notice that where my slope is positive, my derivative is positive. Where my slope is negative, my derivative is negative. Where my slope is positive, my derivative is positive. All right, make sure you bring these to class with you and have a fantastic day.